Hello everyone, this is Anand Goud, Assistant Professor from Civil Engineering Department, Institute of Aeronautical Engineering. So today we are going to discuss about the chain surveying. Topic name is obstacle in chain. So after learning about this topic, we are going to apply these principles to do the chain surveying. So coming to the contents, we are going to discuss about the obstacles in chain. Now, obstacles are nothing but, see, these obstacles. Suppose if you want to measure a distance from point A to point B. Okay. Here, if you have any obstacle, you cannot place the chain or you cannot place the tape over this particular obstacle. So, in this particular type of problems, we are going to face some problems. So, now we are going to choose another parallel line which is having some equal length. Now we are going to measure the distance of this particular line and we are going to equal this particular distance. So like this is how we are going to find out the distance by using the indirect methods. So obstacles to chaining prevent the chainman from measuring directly between the 2 points. Okay, so this obstacle is going to prevent the chainman to measure the distance from point A to point B. Okay, we cannot measure the distance. Okay, and give rise to a set of problems in which distances are found by indirect methods. Okay, so it is going to create problem while measuring the distances. So that is why we are going to follow some indirect methods. Okay, so now if you see this particular image as example, here we have tree. I want to measure the distance from this particular line to this particular line here, like this. Okay, this is point A and this is point B. Now I cannot measure the distance in this particular line because of this particular tree, right? Now what I am doing, I am going to establish one more line which is parallel to the actual line. Now I will measure the distance by using the chain and I am going to equal this distance to this particular line. Okay, this is how we are going to follow the we are going to follow the chain surveying when you get the obstacle. Okay, and here also you can see if you get any lake. Okay, if you have any lake in between the 2 points, okay, then we have to follow some other procedures. Okay, that is what the obstacle. Now here obstacles in chaining are of 3 kinds. Okay, here we have 3 kinds of obstacles. The first one is obstacle to ranging. Okay, the first one is obstacle to ranging, and second one is obstacle to chaining, and third one is obstacles to both chaining and ranging. So about these 3 particular obstacles we are going to discuss now. See, the first one is obstacle to ranging but not chaining. That means here ranging is nothing but you can see the position of the point. Suppose if you have any tree between the points, this is point A and this is point B. Okay, now here see, you cannot see the object here due to this particular position. You cannot see the object another face of the chain line. Okay, but if you take any lake, okay, if you take any lake an example, here see obstacle to ranging but not chaining. So you can apply the chain. Okay, you can place the chain in between these 2 points. Okay, but you cannot see the object. Okay, that is what the obstacle to ranging but not chaining. Okay, this type of obstacle in which the ends are not intervisible. Okay, we cannot see the 2 ends of a chain line is quite common except in a flat country. Okay, if the surface of the earth is or else area is flat, then you can see the objects directly or else other position of the object chain line directly. But here you cannot see the another position of the object. Okay, the ranging is not visible. So here again we have 2 cases. Okay, in this particular type of obstacles also we have 2 cases. The first case is both ends of the line may be visible from intermediate points. Okay, you cannot see the another point from initial point, that is point A, but you can see the point from the intermediate point. Okay, if you establish one point, from this particular point you can see both A and both B. Okay, that is the first case. And this type of obstacles can be overlooked by using the reciprocal ranging. Okay, we have already discussed about the reciprocal ranging in the previous lecture. So just go through that. That is the first case. And second case is both ends of the line may not be visible from intermediate points on the line. Okay, from intermediate points, suppose if you have a line A and B, from this particular point both the ends of the points may not be visible. Okay, in this type of situations we are going to follow another method. Okay, that's it. That is case 2. Now we will discuss about the case 2, that is both the ends of the line may not be visible from intermediate points. See here, first let AB be the one of the line. Okay, just consider line AB. Let AB be the line in which A and B are not visible from intermediate point on it. Suppose this is the point A and this is the point B. Suppose if you establish a point in between these 2 points, then you cannot see the point B. Okay, you may see the point A, but you may not see the point B, or else both the points are not visible, right? So this intermediate point will be established. Okay, now these are the 2 points A and B. Now through A, okay, now through point A, now the same line is represented here, that is AB, or else 2 points A and B. Okay, now through A, draw a random line. Okay, now from point through A, okay, from this particular point A, okay, from this particular point A, you just draw one random line like this. Okay, we are going to draw one random line. Okay, AB1. Okay, this is point A and this is point B1 in any convenient direction. In any convenient direction. So here you can use any direction. Okay, the direction is not fixed, but as nearly towards B. But the point B1 should be as near to the point B. Okay, so from A we are going to draw one line which is very near to the point B. Okay, the direction is not fixed. You can take any one of the directions. Okay, now the point B1 should be chosen, so that, okay, now while choosing this point B1, we have to follow these 2 conditions. The first one is B1 is visible from the B end. So this B1 should be visible from this particular point B. Okay, initially we don't have this line, but we are going to draw one line randomly, that is B1, and when you choose the point B1, that should be visible from point B. Okay, and BB1 is perpendicular to the random line. Now if you join these 2 points like this, okay, this line BB1 should be perpendicular to the line AB1. Okay, so to this particular line, this BB1 line should be perpendicular. That means it is going to maintain an angle of 90 degrees, right? Okay, and measure BB1. So after locating the angle, now measure the distance of BB1. Okay, this is the next step. And next, select C1 and D1 on the random line and erect a perpendicular to C1C and D1D. So now on the random line, this is AB1 random line. So on this particular line, you just choose point C1 and point D1. Okay, these are the 2 points we are going to select. And after selecting the 2 points on the random line, now draw perpendicular lines from C1 as well as from D1. Okay, now we are going to draw the perpendicular lines from these 2 established points on the random line. Okay, this is one line and this is one line, and the angle between these 2 lines should be 90 degrees. Okay, now after determining the points, join C and D and prolong it. Okay, so now after locating the points C and point D, now join this particular CD. Okay, this particular point C and point D should be in line with the point B. Okay, so now after joining these 2 points, now extend it, okay, to get the actual length of the line. Now this is going to give the actual length of the line AB, okay, with the obstacle. Okay, this is the first one. And second type of obstacle is obstacle to chaining but not ranging. Okay, that means we cannot provide a chain Suppose if you have a lake in between the 2 points. Okay, this is point A and this is point B, and here you will be having one lake. Okay, now obstacle to chaining. So here you cannot place the chain to measure the distance between these 2 points. Okay, you cannot place the chain because here we have the obstacle, that is lake. Okay, whenever you are going to do the chain surveying, the surface should be plain. Okay, or else we should not have any type of obstacle. Yeah. So here also again we have two cases. Okay. The first case is when it is possible to chain round the obstacle. Okay, when it is possible to chain round the obstacle, that is pond or hedge. Depends if you have any pond. So you can place the chain around this. Okay, you can use the chain around this. Okay, you can place chain here also, here also. Okay, so we are going to take the examples of pond or hedge. Hedge is nothing but like a fence or any boundary. Okay, yeah. And one more case is when it is not possible to chain round the obstacle. Okay, suppose if you have an obstacle like a lake. Okay, here you cannot place the chain because the lake will be having more length. Okay, here you cannot apply the chain, you cannot place the chain. Okay, this is the another case. Okay, first we will discuss about the first case, that is when it is possible to chain round the obstacle. Okay, in that we have different types of method. The first method is, see, we will discuss about the first method, that is A. Select 2 points A and B on either side. Suppose here we have one lake as an obstacle, suppose one, sorry, pond as an obstacle. Okay, this, now I want to measure the distance, or else I want to measure the width of this particular pond. Okay, for that I am choosing 2 points A and point B on either side of the pond. Okay, select 2 points A and B on either side, that is point A and point B. Set out equal perpendiculars AC and BD. Okay, now from point A, draw one perpendicular line to C, and from point B, draw one more perpendicular to D. Okay, and this is called as a perpendicular AC, and this is called as a perpendicular BD, and the angle is 90 degrees, right? Now measure the distance CD. Okay, now measure the distance CD, and this distance CD will be equals to the distance of AB. Okay, so this is how we are going to find out the length of AB, that is length of the obstacle. When you have obstacle like pond or any fence, then we are going to find out by using this method. Okay, so first initially we are going to have one obstacle, right? So first establish 2 points A and B. Now from A draw one more perpendicular, and from B draw one more perpendicular, and after getting the perpendiculars at some distance with equal distances. Okay, the distance of the lengths of this particular AC and BD should be equal. So after establishing the points C and point D, now join these 2 points, and this length will be equals to the length of the pond or this obstacle. Okay, this is the first method of determining the length of the obstacle. Okay, and now for the same obstacle we have another method. See, this is the obstacle, right? Okay, this is the obstacle we have, and locate 2 points on either side of the obstacle, that is point A and point B. Okay, now set out AC perpendicular to the chain line. Okay, now we have to draw the perpendicular from point A, that is perpendicular AC to the chain line. This is the chain line here, right? So now we are going to draw the perpendicular line, okay, with 90 degrees angle. Now measure AC and BC. Now after establishing the point C, now join these 2 points and then join these 2 points also. Okay, now measure the length of AC and measure the length of BC. Okay, now by using the length of AB will be calculated by using this particular triangulation formulas. Okay, so AB is equals to under root of BC square minus AC square. Okay, by using this formula we are going to find out the length of the AB. Okay, first we have to establish 2 points and then draw one perpendicular line AC, and join the point C with the B. So after measuring the distances of BC and AC, now we are going to use this formula to find out the length of the AB. Okay, this is how we are going to find out the length of an obstacle. Okay, length of the line when you have an obstacle by using second method. And third method is, here I want to measure the distance between 2 points, this A and point B, and here we have obstacle. So now by optical square or crosstalk, find a point C which subtends 90 degrees with A and B. So now by using the crosstalk or else optical square, just locate the point C such that this point C should be perpendicular to the point A, or else it should be, this particular line should have a 90 degrees angle with A and with B. Okay, and next measure AC. Now measure the length of AC and measure the length of BC. Okay, these two sides length will be measured. Okay, after locating the point C such that the angle should be 90 degrees. Okay, now the length of AB will be calculated by using the formula, that is under root of AC square plus BC square. Okay, by using this formula, we are going to find out the length of line AB. Okay, this is the another method. Now, next method is select 2 points C and D on both the sides of A. Now, here I want to measure the distance from point A to point B. Okay, so now we have to establish the 2 points. We have to locate the 2 points, that is point C and point D. Okay, which is either side of the point A. Now, while locating these points at 2 points, that is C and D, these 2 points should be in the same line of AC and AD. Okay, it should be in range with the point A. Okay, now measure the distance AC, AD. Okay, we have to measure the distance AC and AD, and next one BC and BD. Okay, BC and BD. Okay, we have to measure all the sides. Okay, now let angle BCD be equals to theta. Okay, now we are going to equate the angle of this particular BCD with theta. Okay, with theta, and from this particular triangle, okay, you can get the expression, that is triangle BCD. Triangle BCD, we can write that BD square. Okay, BD square is equals to BC square plus CD square minus 2BC into CD cos theta. Okay, from triangulation formulas, we can write this formula. We can get the BD square length. Okay, and from this you can write the cos theta. Okay, we can find out the angle, that is BC square plus CD square minus BD square. Okay, by 2BC into CD. Okay, assume it as a first equation. Okay, mark it as a first equation. Now, from the similar triangle method, so triangle BCA. Okay, triangle BCA. Okay, from triangle BCA, we can write cos theta is equals to BC square. Okay, BC square plus AC square minus AB square by 2BC into AC. Okay, 2BC into AC. Now this is marked as second equation. Now equate these two equations. Okay, equate this cos theta and this cos theta. So after equating this, we can get the length of line AB by using this particular formula. Okay, if you solve that, you will get this notation, this expression. Okay, so from this you can find out the length of AB. Now method E. Okay, now next method for determining the length of 2 points or else a chain line when you get the obstacle. Okay, select any point E and range C in line with AB. So now here select the point E. Okay, here this is the 2 points AB. Now we have to measure the distance between these 2 points. Now to measure that, first we have to locate the point E here. Okay, we just locate the point E. Okay, and range C. Okay, range C in line with AE. Now after locating the point E, now we have to locate one more point, that is C, and the point should be in line with the AE. Okay, it should be in line with AE line. Okay, these 3 points should be in the same line. That is making AE is equals to E. See now, what is the distance here? Okay, the length of this particular line AEC should be equals to AE. Okay, whatever the length is there in between these 2 points, the same length will be marked here in between EC. Okay, and next range D. Okay, establish one more line, one more point. Okay, line D in line with the BE. Okay, in line with the BE. Okay, now in the same line we are going to establish one more point. That means here while marking the point D, the distance should be followed with BE. Okay, that is the same distance will be taken. Okay, whatever the length of the BE is there, that distance will be marked here as a point D, and the point D should be in line with the line B. Okay, now join these 2 points. Okay, join these 2 points. Okay, and measure the distance here. Okay, the distance will be measured, and the length of DC will be equals to length of AB. Now, after marking the point D, measure the distance, and this length will be equals to the length of this particular line, that is chain line. Okay, this is how we are going to find out the length of chain line when you have an abstract line. Okay, this is one more method. Okay, this is, and coming to the next method here. Here also we have to establish we have to measure the length AB. Okay, so select any suitable point E. Okay, select any suitable point E. Okay, here I am going to select the point E on one side of the chain line. Now measure AE. Now measure the distance of AE and B. Okay, these two distances will be measured after establishing the points. Now mark C and D on AE and BE such that CE is equals to AE by N. So now here we are going to mark the distance of point. We are going to mark the point C and D such that the distance between the C and E should be equals to the distance of AE by N. So how many number of parts? You can do any number of parts. Okay, by doing number of parts, we are going to mark this point, and depending upon the number of parts, the formula will change here. CE is equals to AE by N. AE is nothing but total length of the line, and N is nothing but number of parts. How many number of parts you are going to do? Based upon that, you are going to get the CE value. Okay, like this, we are going to establish a point B also. That is BE by N. BE by number of parts N. It may be 3 parts, it may be 2 parts, it may be 4 parts. Okay, now establish the 2 points C and D and measure the distances. Now measure CD. Okay, now after establishing the 2 points, now measure the distance of this particular CD. Okay, CD. Now the length of AB will be calculated by using this formula, that is AB is equals to N into CD. N is nothing but here previously while marking this points C and D, we have done number of divisions here, right? So based upon that, we are going to write the number N here, and CD is equals to the same distance here we have measured. Okay, so from this we can find out the length of the line AB. Okay, this is the another method. So now that is the first case over. Next, coming to the second case, when it is not possible to chain around the abstract. Okay, now if you take the example of lake, so here you cannot place the chain around the around the lake. Okay, you cannot take indirect measurements here, right? By placing the chain. Okay, it will have very long length. So in this particular situation, when you have a long obstacles like this, okay, then we are going to follow the below methods. First one, okay, here now I want to measure the distance between the point A and point B. Okay, this distance I want to measure. Okay, now to measure the distance of this particular length AB, now select point B on one side, and okay, here I am selecting one point, that is B, and A and C on the other side. Now I am selecting two more points, that is A and that is C on another side. Okay, now while locating these 2 points, these 2 points should be in line with the point B. Okay, these three should be in the same line. Okay, now erect AD. Okay, now draw the perpendicular line AD from point A and CE as perpendiculars. Now we are going to draw the CE also as a perpendicular to AB. Okay, now to this particular line we are going to draw two perpendiculars, that is AD and C. Now range B. Okay, range B, D, E in one line. So after, while drawing the perpendiculars, you have to locate the points D and E in line with the point B. Okay, these 3 points should be on the same line. This is how we are going to mark the perpendiculars. Okay, now measure the distance AC. Okay, now here measure the distance AC as well as AD and C. Okay, these three distances are measured here. Okay, so if a line DF, okay, if a line DF is drawn parallel to AB, okay, now if you draw the line DF which is parallel to line AB, cutting this particular CE line at F. Okay, just to draw one line from point D to F. Okay, this point F will be established on the line C. Okay, now, okay, the direction of this particular line is perpendicular to AD, right? So now then triangles ABD and FDV will be similar. So now the triangles ABD and FDE will be similar. So from this particular similar triangles method, we are going to establish the relation, that is AB by AD is equals to AB. Okay, AB by AD is equals to DF by FE. Okay, AB by AD is equals to DF by FE. So now from this we don't know the term FE. Okay, we don't know the length of FE. Okay, that will be calculated by subtracting FE from CE. Okay, we know the distance of CE, right? We know the distance of CE, but we don't know the distance of FE. So from this total length, subtract this FE, this small portion, then you will get the length of FE. Okay, FE. Okay, if you subtract this portion, then you will get the FE value, right? So ECE minus CF. Okay, from the total length, if you subtract this one, you will get the remaining portion, right? Okay, this is the formula CE minus CF. Okay, so that is equals to CE minus AD. Okay, CF will be equals to AD. Okay, like that you can write the formula. Next, DF. Okay, we are going to find out the DF. That is DF. Okay, this length, and this length will be equals to the length of AC, because this AC is already measured, and for this line AC only we are drawing the parallel line. So these two will be having same length. That is why you can take the length of AC. Okay, now AB by AD is equals to AC by CE minus AD. Okay, from which you can find out the AB length. That is AB is equals to AC into AD and CE minus AD. Okay, this is how we are going to find out the length of AB. Now another method, same here again, erect a perpendicular AC. Now from point B is established and from point A is also established on the both the sides of the obstacle. Okay, 2 points are selected on either side of the obstacle. Now erect one perpendicular line AC, okay, and bisect it at D. Okay, from point A, draw one perpendicular line. Okay, after drawing the perpendicular line AC, now just bisect it. Okay, at a point D at the center. Now erect a perpendicular to CE at C. Okay, now from point C, draw one more perpendicular line. Okay, draw one more perpendicular line and range to E. Okay, now this this particular point is aligned with the line BD. Okay, these 3 points should be on the same line. Okay, from point C, draw one perpendicular, and when you establish the point E, and this point should be in line with the line BD. Okay, now measure the distance of CE. Okay, after ranging the BD line, now measure the distance of CE. Now this distance will be equal to the distance of line AB. Okay, so AB is equals to CE. Okay, after measuring the distance, this will be equal to the length of the obstacle, that is the length of the line AB. Okay, this is how we are going to determine the length AB. Next method of establishing, measuring the length. Okay, so now this is the line AB. Okay, this line length will be measured. Okay, now erect a perpendicular AC at A. Okay, now from point A, draw one perpendicular AC. Okay, and choose any convenient point C. Okay, any convenient point C is chosen. Okay, with the help of an optical square, fix a point D. Okay, on the chain line in such a way that BCD is a right angle. Now, by using the optical square equipment, now we are going to fix one point, okay, D on chain line in such a way that the BCD angle should be 90 degrees. Okay, we are going to take the point D in such a way that we don't know the distance, right? So indirectly by measuring the angle between the BCD, we are going to locate the point D. Okay, now measure AC and AD. Okay, now measure the distance of AC and AD. Okay, these two lengths are measured. Now triangles, similar triangles ABC. Okay, from this particular triangle and from triangle DAC are similar, right? So from this we can establish one relation, that is AB by AC. AB by AC is equals to AC by AD. So now from this you can find out the length AB, that is AC square by AD. Okay, by using this formula you can find out the length of line AB. Next point is obstacle to both chaining and ranging. Okay, till now we have seen the obstacle only to ranging. Okay, now here both chaining and ranging. Now see, obstacle to both chaining. For example, a building is a typical example of this type of obstacle. Suppose if you have any building like this, okay, side view, I'm drawing side view, and this is point A and this is point B. Here you cannot see the point B. I want to measure the distance from here to here, but here we have an obstacle like a building. So if you cannot see the point B, as well as you cannot place the chain also, you cannot do the chaining also, you cannot range it, as well as you can not chain it. Okay, so the problem lies in prolonging the line beyond the obstacle. So you cannot draw a line beyond the obstacle, and we cannot determine the distance or cross it. Okay, we cannot determine the distance also from this particular points. Okay, so if you have the obstacles like this, okay, we have some methods to measure the distances. See, this is the building or else one of the obstacle where chaining and ranging is not possible. Okay, now choose 2 points A and B, okay, to one side. Okay, now this is one of the obstacle, right? So on one side I am choosing 2 points, that is point A and point B. Okay, and next, erect perpendicular AC and BD. So now from these 2 points, draw perpendicular lines AC and BD. Okay, these are the perpendicular lines which is drawn from the established points. Okay, and these two lines AC and BD should have the same length. Okay, it should have equal length. Next, join CD. Now join the points CD and prolong it past the obstacle. Okay, to cross this particular obstacle, you just extend the line up to some random length. Okay, now choose 2 points E and F on CD. Okay, now after extending this particular line from points C and D, now choose any 2 points here again. Okay, these 2 points should be in line with the CD. Okay, now after establishing the points E and F, draw the perpendiculars EG and FH. Okay, we have to draw the perpendiculars EG and FH equal to that of AC and BD. So now the length of this particular perpendiculars will be equals to length of BD or AC. Okay, now join GH. So now after drawing the perpendiculars, join these 2 points GH and extend. Okay, now extend. Okay, measure DE. Now measure the distance DE. Okay, now measure the distance DE, and evidently this particular distance DE will be equals to the length BG. Okay, the length of BG is equals to length of D. Okay, now this is how we are going to establish the, we are going to measure the length between B and G when you have an obstacle where the chaining and ranging is not possible. Okay, next one, another method. Select a point A. Okay, select a point A and erect a perpendicular AC. So now this is the obstacle, right? So now I am selecting one point A, and here I am drawing the perpendicular line AC. Okay, just to draw one perpendicular line AC, okay, of any convenient length. Okay, the length you can take any one of the lengths. Okay, now select another point B on the chain line. Now select one more point on the B on the chain line such that AB is equals to AC. Such that AB is equals to AC. So after establishing the point C, okay, just measure the distance of AC. Now with the same distance, establish one more point B that is on the chain line AB. Okay, these two lengths will be equal here. Okay, now join B and C. Okay, join these 2 points B and C and prolong it to any convenient point D. Okay, after joining the point B with C, now extend this particular distance. Okay, extend this particular line to point D. Okay, that is point D at any convenient length. Okay, with random length you just extend it. Now at D, set a right angle DE. Now here at point D, just set one right angle, that is DE, draw one right angle DE such that DE should be equals to DB. Okay, the length of this particular line DE should be equal to length of DB. Okay, yeah. Next, choose another point F on DE. So now here on the line DE, just choose one more point, that is F, such that DE is equals to DB, such that DE is equals to DC. So DF should be equals to DC. So here on the line DE, I am establishing one more point, that is the length, the position of this point should be such that the distance of DF, okay, the distance should be equals to the distance of DC. Okay, by measuring the distance from point C to D with the same distance, draw one more, establish one more point on the DE line. Okay, that is point F. Okay, now with F as center, okay, with F as center, AB as radius, AB as radius, okay, with the same radius here, draw an arc. Okay, draw an arc. Okay, now here we are going to draw an arc here like this. Okay, with F as center, AB as radius, we are going to draw one arc here. Okay, and with E as center, draw another arc of the same radius. Okay, now with the same radius, we are going to draw the one more arc. Okay, like this. Okay, to cut the previous arc G in G. Okay, now to cut this particular previous arc, we are going to draw one more arc from point E, and here we are going to establish a point G. Okay, now join GE. Now join these two particular points GE, which will be in range with the chain line. Now this particular line will be in range with the chain line. Okay, now measure the distance of CF. Okay, after establishing the point G, now measure the distance of CF. Now this length CF will be equals to the length AG. Okay, this length CF will be equals to the length AG. Okay, this is how we are going to find out the length of the line AG. Okay, whenever the chaining and ranging is not possible. Okay, these are the references I have followed. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.